right now, tonight. If you look toward Serpens Cauda, and if you have binoculars, there's a small orange star sitting there. Quiet. The kind of star you'd never notice if you didn't know to look. It's moving toward us. In 1.3 million years, it will pass through the outer edge of our solar system. When it does, it will be the brightest star in the night sky after the sun. Brighter than Sirius. Brighter than Venus on a good night. We won't see it. None of us. Not the people we love, not their children, not the descendants of their descendants, who'll be standing on an Earth that none of us would recognize. But we know it's coming. And we're the first species on this planet that ever did. The star is called Gliese 710. You can find it about 62 light-years away in the constellation Serpens Cauda. That's close by space standards. It would take a light beam from your phone screen 62 years to get there. For most of the 20th century, we knew Gliese 710 existed. We just didn't know it was coming. The closest approach trajectory only became clear when the European Space Agency's Gaia mission measured stellar motion in the Milky Way with a precision we'd never had before. The first refined estimate came out in 2018. The numbers were strange enough that the team recalculated them twice. It is, mathematically, on a course that will bring it closer to our Sun than any known star in modern history. And it will keep coming for the next 1.3 million years. So what is this thing, exactly? And why does it matter that it's heading our way? Gliese 710 is an orange dwarf star, about half the mass of our Sun. Dim. If you replaced the Sun with it tomorrow, you'd wake up to a sky lit by something that looks more like an oil lamp than a star, and Earth would freeze solid in under a year. It's old, slow burning, in the way old stars get when they've stopped having drama. And by every measure, it's completely unremarkable. There are millions of orange dwarfs scattered across the Milky Way. Most of them are minding their own business. This one isn't. I want to be honest about something. When I first read the refined trajectory analysis, I had this feeling I couldn't quite place. It wasn't fear. It was more like reading a weather forecast that says calmly that there's a hurricane out there in the ocean, not coming for you, not yet, but on a track, and the track touches you. So here's what happens when it arrives. Closest approach is in roughly 1.3 million years. The number from the latest refined orbital model is 0.0676 parsecs, about 14,000 astronomical units. That's nearly 500 times farther than Neptune. By stellar standards, terrifyingly close. The closest known approach in recent times was a star called Scholz's star 70,000 years ago, and even that one stayed about 3 times farther away than Gliese 710 will get. When it arrives, the Earth's night sky will change. Gliese 710 is dim by absolute measure, but it will be roughly 20 times closer to us than our current nearest neighbor, Proxima Centauri, is right now. At that distance, even an unremarkable orange dwarf becomes the brightest star in the night sky, possibly bright enough to cast faint shadows on the ground on a clear night. It will hang there in someone's sky for thousands of years, not centuries, thousands. Stellar passages happen on geological timescales. Patient, indifferent to anything as small as a generation. There's one other thing. Our Sun is wrapped in a vast spherical shell of frozen objects called the Oort Cloud. Comets in slow orbits, billions of them. When Gliese 710 passes through the outer part of that shell, its gravity will nudge some of those objects onto new paths. A small fraction will end up falling toward the inner solar system. Millions of years from now, the Earth, or whatever stands in for the Earth, will have more comets to look at than usual. That part will take 10 or 20 million years to play out. But who's there to look? 1.3 million years. Stop and try to fit that number in your head for a moment. Most of us can't. I can't. I've tried. Let me try a different way. Homo sapiens, anatomically modern humans, the actual species you and I are, has been around for about 300,000 years. That's everything. Every culture, every language, every story ever told around every fire. 1.3 million years is about 4 times that. Civilization, the kind with cities and writing, and the assumption that someone tomorrow will read what you wrote today, is about 10,000 years old. The pyramids are roughly half that. The oldest piece of continuously read literature, the Epic of Gilgamesh, is about 4,000 years old. Take the entire history of human writing, lay it end to end 325 times. That's how long until Gliese 710 arrives. I keep trying to feel the size of this, and I can't get there. What I can do is name something that's true. By the time that star reaches us, almost nothing about what we currently call humanity will mean anything. Languages, countries, the idea of going to work in the morning, all of it gone, or transformed into shapes we can't imagine right now. And here's the part that I keep coming back to. This isn't the first time it's happened. Scholz's star is a name almost nobody knows. It's a small binary system, two stars locked in orbit around each other, both very dim. About 70,000 years ago, it punched through our outer Oort Cloud at a distance of 0.8 light-years, closer than Gliese 710 will ever come. At the time, anatomically modern humans were already on Earth. They were in Africa. They were just starting to push north into the Levant. Some of them, somewhere, must have looked up and noticed a faint red dot drifting through their sky over a few generations. They didn't know what it was. They couldn't have. Astronomers worked out Scholz's trajectory in 2015 by running the math backward. And there's another one. Around 2.5 million years ago, before there were humans at all, another star came in even closer, possibly inside half a light year, according to recent refined estimates from Gaia data. Whatever was alive on Earth back then, ancestors of ours that we'd barely recognize as kin, saw a star drifting through their sky for thousands of generations. They had no language for what they were looking at. We do have a language for it. That's the strange part of this whole story. Not the catastrophe, not even the time. The strange part is that we, sitting here in 2026, are the first generation on this planet who's ever known that a star was coming in advance with math. Every previous stellar visit happened blind. No one charted the trajectory. No one alive could have seen the math even if they wanted to, until now. Imagine for a moment that people in the Bronze Age could have predicted a solar eclipse 50,000 years in advance, with certainty to the year. They couldn't have imagined it as anything but magic. That's roughly what we just did with Gliese 710. We've reached a point in our understanding of the universe where we can see things that don't matter to our lives at all. Things that will happen long after every culture we belong to is gone. And I think about this sometimes. About how strange it is to know something useful for nobody who's currently alive. Other species deal with the world that's in front of them, the next meal, the next predator. We do all that too. But somewhere along the way, we picked up this extra habit of caring about events on timescales that have nothing to do with us. Asteroids that won't pass for centuries. The slow drift of continents that completes long after every government we know is gone. And a small orange star approaching our sun for 1.3 million years. It's the most quietly amazing thing humans do. We won't see it. None of us. Not our children. Not the people who'll be alive in the year 4000 or 20,000. The whole stretch of recorded human history, end to end, is a tiny fraction of the time between now and that arrival. There's something about that I find unexpectedly peaceful, and I want to say why. For most of human history, the question of what the sky will look like after I die wasn't a question anyone asked. The sky was the sky. The same constellations that watched over the first farmers in Mesopotamia would watch over their grandchildren. Whatever stories people told about the stars, the physical configuration was a constant. We know now that it isn't. The sky is in slow, constant motion. Stars drift in and out of our neighborhood on million-year cycles. Gliese 710 isn't the exception. It's the rule we hadn't noticed yet. And it moves on its own trajectory. Earth moves on its own. The two will meet. With us, without us. Gliese 710 doesn't know we exist. It doesn't need to. If sitting with something on this scale changes how you think about your week, I'd like to hear about it. Tell me in the comments. And if you want more of the slow kind of cosmic thinking, subscribe. But there's one more thing about what this means right now. Tonight, somewhere in Serpens Cauda, that small orange star is sitting in your sky. You can't see it without binoculars, but it's there, and the trajectory is in peer-reviewed papers that anyone with an internet connection can read. The fact that it's coming is no longer hidden in any way. That's the part I keep coming back to. Of every species that has ever lived on this planet, every human ancestor who ever wondered what those points of light were, we are the first who can look at that small dot, knowing what we now know, and say the words it deserves. You are coming. And we noticed. It's a small thing. It costs us nothing. But it's the first time in 4.5 billion years of life on Earth that any of us did. We're dust on a draft between stars. For one brief moment, we knew it, and we paid attention.